Hello friends, welcome to True Event Academy. In the last lecture we have discussed up to question number 9. So we will discuss question number 10 onwards in this particular lecture. So basically we are discussing the problems on the constraint motion. So in the last lecture we have discussed up to question number 9. So we will discuss question number 10 onwards in this particular lecture. So let's start our discussion. So what is given in the question is that the particle is projected from the lowest point inside a smooth circle of radius A. So we have a smooth circle of radius A and a particle is projected from the lowest point with a velocity due to a height h above the center. So this is center. So velocity due to height h above the center. The net height. So net height from this point. Let us consider this point as k. From the point k, the net height of this particle is a plus h. Okay, so this is a plus h is the net height. So what will be the velocity? So we have velocity is equal to 2g into height. Let us consider this as h dash. Okay. So we have root under 2g. So initial velocity we consider this as u. Okay. So let us take this as u. So u is equal to 2g into a plus h. Okay. So this is our initial velocity. So the particle is projected with a initial velocity of 2g a plus h. Let us rub this. Okay, so initial velocity is 2g of a plus. Okay, the particle is projected from the lowest point inside a smooth circle of radius a with a velocity due to height h. The velocity is 2g a plus h above the center. Find the point where it leaves the circle and show that it will afterwards pass through the center if h is equal to half a root 3 or lowest point if h is equal to 3a upon 4. So let us consider at an angle of theta 1, the particle, the tension becomes, the reaction becomes 0. Okay, so R is equal to 0. Let us consider at an angle of theta 1, the reaction becomes 0. By this we mean that by the statement that reaction becomes 0, we mean that at this particular point the particle will leave the circular motion. Okay, it will leave the circle and will start following the parabolic path like this. It will start following a parabolic path. Okay, so we have to find this height. At what height from the center it will leave the circular motion. Okay, so let us consider this. So let us write down the equation for reaction at random theta. Random theta is R is equal to mu square upon a minus mg 2 minus 3 cos theta. Okay, so let at theta is equal to theta 1, our reaction is equal to 0. This means 0 is equal to m upon a into initial velocity is 2g a plus h minus mg 2 minus 3 cos theta 1. Okay, so we have this as 2 mg upon a plus h is equal to mg 2 minus 3 cos theta 1. Okay, so we have this as mg gets cancelled. So 2 plus 2h upon a is equal to 2 minus 3 cos theta 1. So we have this gets cancelled. So we have cos theta 1 is equal to minus 2h upon 3a. Okay. So this is our angle. Cos theta 1 is equal to minus 2h upon 3a. So this is cos theta 1. So this angle, let us consider this as alpha. This angle is alpha. So alpha is equal to, this angle is theta 1. So this angle will be pi minus theta 1. Pi minus theta 1. Similarly, this angle will also be alpha. Okay, so we have to find this height. So let us consider this as small h. So we have, let us name this. So this is O, this is A, and this is B, and this is C. So the BC is equal to OB. This is alpha. So the OB cos alpha. Okay, is equal to OB is radius. So A into cos alpha. Cos alpha is equal to A. Cos alpha is pi minus theta 1. So this is cos of pi minus theta 1. Okay, so the cos pi minus theta 1 is minus cos theta 1. So we have BC is equal to minus A cos theta 1. Okay, so BC is equal to minus A into cos theta 1 is minus 2h upon 3a. This means BC is equal to 2h upon 3. So at a height of 2h upon 3, from the center, it will leave the circle and follows a parabolic path. Okay, so let us proceed for solving the part A of this question. This is clear. So we have cos theta 1 is equal to minus 2h upon 3a. So we have cos theta 1 is equal to minus 2h upon 3. So this is like this. At an angle of theta 1, we have the particle leaves the circle and follows a parabolic path. So this path is like this. So in the first case, this particle passes through the center. So it will follow the parabolic path like this and passes through the center. Okay, so this is center and this distance is A. Okay, so this is alpha and this is alpha. Okay, so let us consider this as a reference point. This is O, this is B, this is A and C. Considering the reference point as B, which is the starting point of the projectile motion, let us consider this as a reference point. So we will take this as positive, this as positive. Okay. So in this direction, so what will be the coordinate of O? Coordinate of O is, so this distance will be, this is alpha, so we have A sin alpha and this is A cos alpha. So this will be, the coordinate of center is A sin alpha and minus A cos alpha. Okay. So let us write down the, and at point B, the velocity of the projectile is V1. Let us say, let us consider the velocity as V1 at point B, and initial velocity is U is equal to 2g A plus h root under. Okay. So we have the final velocity as V1 at point B. Okay. So we have V1 square is equal to initial velocity square 2g A plus h minus 2ag into 1 minus cos theta 1. Okay, so we have V1 square is equal to 2g A plus h minus 2ag 1 plus 2h upon 3. So we have 2g common, A plus h minus A minus 2h upon 3. So this gets cancelled. So we have 2g into, this is 3h, to h upon 3, V1 square. Therefore, V1 is equal to 2gh upon 3 root under. So the velocity of the projectile at point B is initial velocity of the projectile, I mean to say 2gh upon 3 root. Okay, and the alpha is equal to pi minus theta 1. Okay, so we have cos theta 1 is equal to minus 2h upon 3a. So we have cos alpha is equal to cos of pi minus theta 1. This is equal to minus cos theta 1. This is 2h upon 3a. Cos alpha is equal. So the cos alpha is equal to 2h upon 3a. So let us write down the equation of trajectory. So using the equation of trajectory, we can solve these two parts of this question. Equation of trajectory with initial velocity v1 is equal to 2gh upon 3 and alpha is equal to cos inverse 2h upon 3. So y is equal to x tan alpha minus gx square upon 2 v1 square. The 2 into 2gh upon 3 cos square alpha. Okay. So we have y is equal to x tan alpha minus 3. This gets cancelled. So 3x square upon 4h cos square. Okay. So now this is the equation of trajectory. So let us write down separately for solving two parts of this question. The equation of trajectory. Y is equal to x tan alpha minus 3x square upon 4h cos square. Okay. Now in case 1 it passes through the center, and the coordinate of center we have found as in part A, particle passes through center. Okay, the coordinate of center is A sin alpha minus A cos alpha. Let us put this coordinate in this equation of trajectory. So we have minus A cos alpha is equal to A sin alpha into tan alpha. Sin alpha upon cos alpha minus 3 upon 4h into x square is A square sin square alpha upon 4h cos square. So we have this is minus A cos alpha is equal to A sin square alpha upon cos alpha minus 3A square sin square alpha upon 4h cos square alpha. Okay, so we have this as 3A square sin square alpha upon 4h cos square alpha is equal to A upon cos alpha sin square alpha plus cos square alpha. This is 1 is equal to A upon cos alpha. Okay, let us further simplify this. Okay, we have 3 A square sin square alpha upon 4h cos square alpha is equal to A upon cos alpha. So this gets cancelled. Okay, and cos alpha gets cancelled. This can be further simplified as 3a sin square alpha is equal to 4h cos alpha. Okay, so 3a into 1 minus cos square alpha is equal to 4h cos alpha. So 3a into 1 minus cos alpha is 2h upon 3a. Cos alpha is 2h upon 3a. 1 minus 4h square upon 9a square is equal to 4h into 2h upon 3a. This is equal to 8h square 8h square upon 3a. Okay, let us further simplify this. So we have this as 1 minus 4h square upon 9a square is equal to 8h square upon 9a. Okay, so we have 1 is equal to h square upon a square into 4 upon 9 plus 8 upon. This is equal to h square upon a square into 12 upon 9. So this is 4 3 is 12, 3 3 is 4 upon 3. So we have h square is equal to h square is equal to 3a square upon 4. This means h is equal to root under 3a square upon. This is root 3a upon 2. So h is equal to root 3a upon 2 is the height. Is the is the if the particle is passing through the center, the if h is equal to root 3a upon 2. So if h is equal to root 3a upon 2, then the particle will passes through the center, as this coordinate is satisfying the equation of trajectory. Okay, so let us solve the question part B of this question. So in the part B we have passes through the lowest point. Let us rub the trajectory. So in this particular case it will pass the center through the lowest point. Sorry. Okay, so in part B, the particle passes through lowest point. Okay, so if it is passing through the lowest point, then our trajectory will be like this. Okay, so the lowest point will be, the coordinate is a sin alpha, and this is a cos alpha, and this is a. So this will be minus of a 1 plus cos alpha. Okay, so we have, let us put these coordinates in the equation of trajectory. So we have minus a 1 plus cos alpha is equal to a sin alpha into sin alpha upon cos alpha minus 3 into a square sin square alpha upon 4h cos square. Okay, so we have this as 3 a square sin square alpha upon 4h cos square alpha is equal to a of a upon cos alpha sin square alpha plus cos square alpha plus a. Okay, so this is equal to a 1 plus cos alpha upon cos alpha. Okay, so we have this as 3a square sin square alpha upon 4h cos square alpha is equal to a 1 plus cos alpha upon cos alpha. Okay, so let us further simplify this. So we have 3a square into 1 minus sin square alpha, we can write 1 minus cos square alpha, and this we can write 1 minus cos alpha into 1 plus cos alpha. Cos alpha into 1 plus cos alpha divided by 4h cos square alpha is equal to a into 1 plus cos alpha upon cos alpha. This gets cancelled. Okay, and cos alpha gets cancelled. What we will get is that we have this as, and a gets cancelled. 1 minus cos alpha upon cos alpha is equal to 4h upon 3a. Okay, so we have 1 minus cos alpha is equal to 4h upon 3a into cos alpha. Cos alpha is 2h upon 3. So 1 minus cos alpha is 2h upon 3 is equal to 8h square. This is 8h square upon 9a. Let us further simplify this. So we have 3a minus 2h upon 3a is equal to 8h square upon 9a square. So we have 3 gets cancelled and a gets cancelled. So we have 9a minus, sorry, 3a into 3a minus 2h is equal to 8h square. So we have 9a square minus 6ah equal to 8h square. So we have this as 9a square minus 6ah minus 8h square is equal to 0. So we have this as 9 is 72. So we can simplify this as 12 minus 6. 12 check 12 into 6. So 12 minus 6. So this is equal to 9a square minus 12ah plus 6ah minus 8h square is equal to 0. We have 3a minus 4h plus 2h 2h into 3a minus 4h is equal to 0. So we have 2a plus 2h into 3a minus 4h is equal to 0. This is not equal to 0. So 3a minus 4h is equal to 0. This means h is equal to 3a upon. So if h is equal to 3a upon 4, then this projectile will pass through the bottommost point, that is lowest point. Okay, because this coordinate a sin alpha and minus a 1 plus cos alpha is satisfying the equation of trajectory. Okay, so let us discuss question number 11. So what is given in the question is that a particle is projected along the inside of a smooth vertical circle of radius a. Okay, particle is projected from inside a smooth vertical circle of radius a. This is the radius a from the lowest point. Show that the velocity of projection required in order that after leaving the circle, the particle may pass through the center. So let us consider at an angle theta 1, it leaves the circle and it passes through the lowest point. So this is the path of the projectile. Okay, so it is passing through the lowest point. So let us find theta 1 first. Okay, so at theta 1, this particle is leaving the circle. This means r is equal to 0 here. Okay, so we have, let us write down the solution. So we know that the reaction so that the velocity of product. Okay, so we know that the reaction at random theta is given as if initial velocity is u. Let us consider the initial velocity as u. So we have r is equal to mu square upon a minus mg 2 minus 3 cos 2. Okay, so let at theta is equal to theta 1, r is equal to 0. So we have 0 is equal to mu square upon a minus mg 2 minus 3 cos theta 1. Okay, so we have 2 minus 3 cos theta 1 is equal to mu square upon a into 1 upon mg, which is equal to u square upon ag. So 3 cos theta 1 is equal to 2 minus u square upon ag. This is equal to 2ag minus u square upon ag. So we have cos theta 1 is equal to 2ag minus u square upon 3ag. Okay, this is cos theta 1. So at an angle of theta 1, the particle leaves the circle and follow a parabolic path. Now let us write down the equation of trajectory. So this angle is theta 1. So this angle, let us consider this as alpha. This angle will also be alpha. So this is our velocity of the projectile. This angle will also be alpha. And alpha is equal to, this angle alpha is equal to pi minus theta 1. This is also pi minus theta 1. So cos alpha is equal to cos of pi minus theta 1 is equal to minus cos theta 1. So cos alpha is equal to u square minus 2ag upon 3a. Okay, so um, let us write down the general equation of a particle at a random theta. At a random theta, we have the reaction as r. Okay, mg. Okay, the weight acting in a downward direction, and this is theta. So this angle will also be theta. So this is mg cos theta. And there is a centrifugal force inside, mu square upon mv square upon a. So force balancing equation will be r minus mg cos theta is equal to mv square upon a. Okay. So at theta is equal to theta 1, we have r is equal to 0 and v is equal to v1. So the velocity of projectile is v1 at theta 1. So we have minus mg cos theta 1 is equal to m v1 square upon a. So minus of cos theta 1 is cos alpha. So this we can write mg cos alpha is equal to m v1 square upon a. So this gets cancelled. So we have v1 square is equal to ag cos alpha. v1 is equal to root under ag cos alpha. Okay. So now let us write down the equation of, so we have this as V1 is equal to root under Ag cos alpha, ठीक है, और cos alpha is equal to u square minus 2Ag upon 3Ag. So let us write down the equation of trajectory. So the equation of trajectory, y is equal to x tan alpha minus gx square upon 2 v1 square cos square alpha. So we have y is equal to x tan alpha minus gx square upon 2 into v1. So v1 की value ag v1 square ag into cos alpha into cos square alpha. So we have this gets cancelled. So we have y is equal to x tan alpha minus x square upon 2a cos q alpha. Okay, so this is the equation of trajectory. So what is equation of trajectory? Equation of trajectory is y is equal to x tan alpha minus x square upon 2a cos q alpha. Okay, so our the lowest point is, sorry. So that the velocity of projection required in order that after leaving the circle the particle may pass the center. Sorry, it is passing through the center. Particle is passing through the center like this. Okay, so I will draw this diagram again. Cos theta 1 क्या था? Cos theta 1 is equal to 2Ag minus u square upon 3A. ठीक है. So what is our so at an angle of theta 1, so at an angle of theta 1 the particle leaves the circle and starts following a parabolic path and it will pass through the center. Okay, so this angle is alpha. This angle is also alpha. This is A. So this is A cos alpha and this is A sin alpha. Okay, and here the projectile motion gets started. So V1 square. Okay, so V1. So V1 is the velocity is equal to Ag cos alpha root under. And initial velocity is we have to find. Let us consider this as u. So let us put these coordinates in the equation of trajectory. The coordinate is a sin alpha. So in this direction we are considering positive because we are taking the coordinate of center with respect to this reference point B. Okay, so let us name this. This is B, this is O, and this is A. So the coordinate of center is A sin alpha. Coordinate of the center is A sin alpha or minus A cos alpha. Let us put this in equation of trajectory. So we have minus A cos alpha is equal to A sin alpha into sin alpha upon cos alpha minus A square sin square alpha upon 2A cos cube alpha. Okay, so now let us further simplify this. So we have A square sin square alpha upon 2A cos cube alpha is equal to A sin square alpha upon cos alpha plus A cos alpha. So this is equal to A upon cos alpha. A square sin square alpha upon 2A cos cube alpha. Okay, so this gets cancelled and this gets cancelled. So we have sin square alpha and is equal to 2 times of cos square alpha. 1 minus cos square alpha is equal to 2 cos square alpha. So we have 1 is equal to 3 cos square alpha. So cos alpha is equal to 1 upon root 3. Okay. So now we are having, so we have cos alpha is equal to 1 upon root 3. Okay. So we have cos theta 1 as 2 ag minus u square upon 3 ag. And cos alpha is equal to cos of pi minus theta 1. This is minus cos theta 1. This is equal to u square minus 2ag upon 3ag. Okay, and cos alpha is 1 upon root 3. Okay, so we have 3ag upon root 3 is equal to u square minus 2ag. So this gets cancelled. This is root 3. So we have u square is equal to 2 plus root 3 into ag. Okay, so this we can further simplify as u square is equal to 2 plus root 3 into ag. This we can write as u square. So 2 plus root 3 whole square. Sorry, 1 plus. What is the expansion of 1 plus root 3 whole square? 1 plus root 3 whole square is equal to 1 plus 3 plus 2 root 3. This is 4 plus 2 root 3. So this we can write as 4 plus 2 root 3 upon 2. Okay, Ag. So u square is equal to this. We can replace this with 1 plus root 3 whole square. The 4 plus 2 root 3 we can replace with 1 plus root 3 whole square. So 1 plus root 3 whole square upon 2 ag. Okay. So now we can simplify this as u is equal to 1 plus root 3 into ag upon 2 ka under root. Okay. This is our answer. The u is equal to ag upon 2 under root into root 3 plus 1. Okay. This is our initial velocity. This is being asked in the question. Okay. So we will further discuss further questions in next particular lecture. Thank you.